TikTok is one of the biggest companies in the world with 1 billion monthly active users. TikTok is most famously known for its algorithm and has been popularized by the media. But what is it? And can I make my own? You've come to the right place. In this video, we'll explain the basics of the algorithm and how to make your own, without any crazy mathematical jargon and just a straightforward tutorial. So let's get to it. So there are some clues online as to what the TikTok algorithm does, but one of the biggest clues is done in a TED Talk by TikTok CEO Shu Chu.
I'm going to simplify this a lot, but the machine learning, the recommendation algorithm is really just math. So for example, if you liked videos 1, 2, 3, and 4, and I liked videos 1, 2, 3, and 5, maybe he liked videos 1, 2, 3, and 6, then what's going to happen is, because we like 1, 2, 3 at the same time, he's going to be shown 4, 5, 6, and so are we. And you can think about this.
So basically, he's talking about a form of collaborative filtering, which is a technique in data science used to recommend items to users. So the TikTok algorithm basically takes in all the data from the users in terms of views, likes, uses it to train the model, and outputs recommendations to other TikTok users. But don't worry, we'll break this down step by step in this video. So here goes. Okay, so this is my own personal example for explaining how collaborative filtering works. So I found this useful, so hopefully you find this useful as well. So imagine that we have these 3 users. So we have John, Bob, and Sarah. And we have these 3 films on the right. So we have Marvel's Avengers, Mission Impossible, and John Wick. So let's say, for example, John, as Bob, likes Mission Impossible and John Wick chapter. We have Sarah here that has only seen John Wick chapter 4. Now the algorithm will go and see all this data, and as a simplistic example, because Bob also watched Mission Impossible and John Wick 4, the algorithm is going to recommend Mission Impossible to Sarah because she's also seen John Wick 4. Okay, so before we dive into the actual tutorial for implicit, so we'll firstly explain what the difference is between implicit and explicit data. So let's look into the Google definition. So explicit data is when data from the user that is specifically used in terms of a positive or negative interaction of the user. So, for example, liking or favoriting or buying a product or rating a film would be considered as explicit data that indicates this is a positive or negative interaction from the customer. With implicit data, it's not directly defined as positive or negative data. It's just user behavior in terms of its interaction with the item or product. So, for example, when a customer views a product but doesn't make a purchase, or when a customer views a film on Netflix or looks at a video on TikTok, etc. These can be considered as implicit data because it's not a direct positive or negative interaction. It's just simply a user behavior interaction for that product or the user. Yeah, so for this tutorial, essentially we're going to be using the implicit library, and we're going to be using Benfred's implicit library for this. So this is all open source, and he provides this completely for free. This is just going to be a video kind of explaining how to use it, essentially. But yeah, it provides really great links, really great examples to use from, really simple to use. And I'll provide these links in the description below for this video as well. So this is the GitHub for it. It's like very popular, obviously, a lot of stars. And he's also got a separate link for this. He's made a GitHub webpage for this. So essentially going through the basic usage, documenting how it's used. For this particular YouTube video, I'm going to be going through this tutorial. Again, I'll put the link for this below in the description, but essentially, yeah, tutorial on how it's used, basically. Essentially go through the dataset. So essentially, we're using from the example from the implicit library, and we're just using the data set here because it's perfectly formatted for this tutorial. So this is actually the most important part for actually using this algorithm. The algorithm is actually fairly easy to use. It's just getting the data into the right format it can be quite hard, can be quite tricky, and it's computationally is quite expensive sometimes. So the example uses get last fm. So this data set here. So we'll just go to it here. So yeah, essentially just using this open source data set here, which contains, as it says here, user, artists, and plays. And this is in the form of tuples, and it's collected from the API. So they just go through some examples here, what it kind of looks like. So it starts off with user first, ID, artist name, plays, and it provides some examples what it looks like. So it's separated by like a tab delimiter, for example. So we'll just go over, we'll just print a statement, see what the data actually looks like. So if we do print, so the one that's actually useful to us is artist user plays. So we just have a look, see what it looks like. Oh, run the whole thing. Okay, so essentially when we print the data, so it comes with this data format. So this is really important for using the implicit library and this recommendation out. So the data must be formatted in such a way so it's in the form of the matrix, tuples, with artists, the user ID, and the number of plays it has. So it must be formatted in this way in order for the algorithm to work. Yeah, so the next part of this is going to be the manipulation of the matrix and just putting it into a format that's good for the recommendation algorithm. So this first part here, you don't have to do this, but it's really useful. So it's about weighting the plays on it. So, for example, you don't want to have a spammy bot that's just pressing plays or likes on a particular artist and affecting the algorithm. So, obviously, you want the most popular artist to be recommended, but you don't want it to be like a super fan just spamming likes on an artist and just getting that recommended to artists. So, you want it to even out and have a weighted matrix to counteract that effect. So essentially, you just kind of use this codes and essentially it's to weight the matrix to reduce the impact of users that play the same artist thousands of times and to reduce the weight given to popular items. So that's essentially in a nutshell what it does. And once we have this, we'll get a transpose of the matrix to put it in a format that's good for the recommendation algorithm. So yeah, so essentially the algorithm expects user item sparse matrices instead of item user. So essentially just reversing the two items together and putting it in a suitable format for the recommendation algorithm. Okay, so basically done the first parts of the algorithm. So we've got the data, the weightings. So now it's time to actually train the model. So essentially, we're going to be using the implicit library's alternating least squares algorithm. I'll probably make another video on this algorithm, but essentially it's a collaborative filtering algorithm that essentially uses the matrix and essentially takes in all the data from views, likes, user item interactions, and essentially trains it and allows you to play with the model and make recommendations from the model. So once we have our model trained, so we're going to have our recommendations to do essentially. So we're going to have first show an example of what a recommendation look like for a single user. So see, we have this user ID here. And so this is a line of code to essentially make recommendations from the model. And we'll just play this. And You can actually also filter on items that they already like. So, meaning that you just want to show the items that they've not previously seen or liked before, you can do that. N is the number of items that you want to recommend. Um, and this is just the format in order to get the data based on a single user ID. So once that's played, it's recommended, and we just need to display it in a output for us to see. So I'll just play this. And so you can see, yeah, based on kind of see what the based on what the user already liked is true, um, and you can see what artist has been recommended. And obviously, the higher the score, uh, like the better the match it is for that user, based on what previous songs they played or which artists they played before. Yeah, so this is just a simple example for recommendations for the single user. So as you can see, it's actually quite simple, the codes. You just need to format the data correctly and yeah, display the data in the way that you want. Okay, so the next part is once we are able to provide recommendations for single user, we can simply provide recommendations for an artist. So getting related items for example, the artist the Beatles. So we'll just run this example here. So an example, real life example, might be Spotify or Netflix, where you say you view a certain film, it would probably show you recommendations on other similar films as well. Or likewise, Spotify, if you listen to a certain artist, it would recommend items similar to that artist. So for the Beatles, you can see there's one for the Beatles itself, but it shows you other similar artists that people viewed. So Rolling Stones, Beach Boys, and just some sense checking. You know, this is kind of roughly correct, right? Like, obviously, you know something's wrong if it suddenly recommends like Drake or Jay Z or something when you want artists similar to the Beatles. So just sense checking looks about right, and the algorithm is doing uh, what you intended it to do.
So there you have it. So that was a very simple Python tutorial for making essentially your own TikTok style algorithm. So hopefully you found it useful. And if you enjoyed this content and found it useful, please comment, like, and subscribe.